in here, we have Intel's flagship 6980p Xeon CPU, 128 cores in our Supermicro platform. This is the fastest, the highest end, the flagship CPU from Intel. This is the CPU that Intel launched almost, not quite, a year ago that gave AMD's Zen 4 a run for its money. In fact, it beat Zen 4 in basically every category. It's entered mainstream. I mean, it launched last year, but it's entered mainstream availability. It's in high production. This system is shipping in quantity, and it is still a thumping fast system. Let's take a closer look at the chassis configuration, give you some ideas for how this might slot into your enterprise configuration, and take a look at what I've got coming up next, which is to use it for storage testing. I've got 8 MemBlaze PBlaze 7 to 7A40. These are Gen 5 NVMe, 15 gigabytes per second. And this is some of the fastest storage benchmarking that I've ever been able to do on this platform. And some AI stuff. I got into some AI stuff. We've got some really amazing AI stuff on Hugging Face because you can run the memory. I mean, MRDIMMs up to 8800 on Intel's platform. That's pretty good for AI. Let's take a closer look. The Hyper SuperServer? Yes, this is the Hyper SuperServer from Supermicro. To be specific, Hyper SuperServer SYS-212HA-TN. Supermicro recommends this for virtualization, software-defined storage, AI inferencing and machine learning, cloud computing, enterprise server, data center optimized, database processing, and high-density storage. If you are looking at this for a virtualization host, might I also recommend you look at the 6970p processor from Intel. Get the 2.7 gigahertz base. It's not quite as many cores, but the cores you have are quite fast. As always, Supermicro comes with a standard 2U chassis. At the rear, this thing is configured with two 1600 watt power supplies. Now, this is a single CPU platform, and our CPU is a TDP of 500 watts. Most of that wattage is designed to go for your full height, full length PCIe expansion slots. So all your PCIe lanes are routed to the front, basically, in this particular chassis configuration. So if we take a look at our rear layout here, we've got dual 1600 watt power supplies, our management Ethernet interface, dual USB, standard VGA, and we've got a stack of OCP3 slots. Now, if you're not familiar with OCP3, this is 16 PCIe Gen 5 lanes, and there are a whole bunch of OCP accessories available. You can even go things like FPGAs. In our configuration here, I've got a dual 10 gig adapter, but you could also do dual 100 gig. You could do quad 25 gig. You could do 200 gig. There's a lot of OCP3 peripherals that are available. There are even a few that are double height, so you could actually take advantage of the double slot here, or you can just have two peripherals, one stacked on top of another. There are even FPGA and security appliance OCP3 accessories. And then, of course, you have your standard PCIe slots, full height, full length at the back. Now at the front, I have 8 U.2 bays. Our 8 U.2 bays are PCIe Gen 5. You can get this chassis configured for up to 24 NVMe at the front, but I've got some different configuration stuff in mind, maybe running some GPU workloads and doing some GPU testing. And so in this configuration, most of our PCIe lanes are at the back. Inside, if I can get our duct baffle out of the way, I've had some adventures with different configurations that I've been working on already. There's our giant socket. This is designed for the 6900 series Xeon processors that we took a look at last year. We have 12 memory channels in this configuration. Our motherboard has connectivity for 2M.2 that you can use for your boot drive or your OS drive. That's what I'm taking advantage of. I'm using, that for my OS drive. And then we've got a number of MCIO connections. Now the MCIO connections here break out and go to our PCIe slots. We can see that our PCIe slot PCBs are connected only via the MCIO cables. This is pretty modern. This is how it's done. This also means that this motherboard is reusable across a whole bunch of different chassis configurations. That's great for enterprise serviceability. It's great for reliability. It's great for modularity. I like to see this aspect of the design. It's very good that Supermicro approaches the design this way because even as you need different things in the enterprise, your chassis are still going to be reasonably standardized. You can have a reasonable set of standardized parts that will apply across a whole bunch of different SKUs. You can also choose, if you need 8 or 16 lanes. You can also do fancy things like some peripherals are actually, it looks like it's an X16 peripheral, but it's actually a peripheral that has 2 X8 interfaces. Take, for example, our smart modular device. This has 8 DDR5 memory slots on board. This is a CXL memory expansion device, Type 2, from Smart Modular. And I've reviewed these separately. And this works great with this platform. But this is not an X16 peripheral. This is actually two X8 peripherals on one card. Now, if you configure bifurcation, in the BIOS, you can use this on a single slot, and that's all well and good. But if this were a 2-processor system, you could actually split the slot and have 8 lanes run to one processor socket and the other 8 lanes run to the other processor socket. As this is a single socket system, you don't really need to do that. But if this were a 2-socket system, that is an awesome feature of this peripheral, and this chassis design means that these components will work for that use case. So spare parts and reusability and all that. It's good. That's what I mean. It's good design, even when you go way into the weeds with something like this. And then our riser on the other side gives us room for 2 full-height, full-length GPUs. And you can see that we have our GPU mounting hardware accessories here, so you can actually physically mount the GPU so that it doesn't run around. If you wanted to run like dual Max-Q NVIDIA GPUs on this is not a problem. And your power supply would still be overkill because you've got, let's say 750 watts power budget here, and then another 600 watts from 2 Max-Q GPUs. You still got plenty of power budget left for other accessories. Maybe a 200 gigabit NIC or something that's going to use a lot of power. It's not a problem. And in this layout, you're going to have more than ample airflow for those Max-Q GPUs. Now, as this is cabled, we have 8 lanes via this cable. There's no lanes cabled for this connector. The bottom slot is full X16 from the motherboard. And then this slot has a sticker over it that says, hey, you're going to need a PCIe cable in order to enable this slot. And the connector for that is there. Also want to call special attention to our giant heatsink with this. Now, the baffle is critically important so that you get adequate airflow over your DIMMs. When you're running 8800 MR DIMMs, if they don't have sufficient cooling, you can see the voltage regulation part of it go up to like 105, 110 degrees C. So the airflow over this area is critical. And our 6980p is top stack. It's going to produce a lot of heat. You want to keep it cool, but you also don't want the system to be overly loud. And so the cooling solution here, because it has heat pipes and it has some extra heat sink that's toward the front here, that's why I want to call it out, because this helps that 6980p stay cool and boost longer. And, the boost algorithm and all of that, the CPU is going to perform better just because it has better cooling. It may be thermally limited as opposed to power limited. And so the CPU is basically going to run at 500 watts all the time, as long as you can keep it cool. And this cooling solution will keep it cool, but also keep it cool without, being as hard on your hearing as it would have been with the less surface area. As always, Supermicro makes it really easy to replace cooling in your chassis. You just got to squeeze and remove. You're good to go. And then you can see our NVMe layout. Our 8 NVMe use 4 8-lane connections. And so that's really the long and short of it. There's really not a lot else to see inside this motherboard. Oh, you can also see, you might be wondering what the small connectors are. Those are for power. You can use those for breakout power, because all of the power from the power supplies goes to the motherboard, and then the motherboard can supply the GPUs 300 watts or 600 watts through those motherboard connectors. There's also an unused 20-pin header for USB 3, so you could use an internal breakout for USB storage if you do that, but that's like basically nobody does that anymore. If you're upgrading from like old VMware where it was stored on USB, we don't do it that way anymore, so you probably don't need that. Are you thinking about this platform with a couple of H100s and then a terabyte of memory for your AI researchers? Yes, you can do the hybrid thing as well. That's where you're running inferencing and workloads on a GPU or 2 in this platform, plus your CPU. And that is also a viable, affordable way to do some really interesting stuff. Although now that Blackwell is out, you really should be looking at like the Max-Q or some variant of Blackwell. Like, Jensen wasn't kidding when he said,
when Blackwell starts shipping in volume, you couldn't give hoppers away.
Oh, I'm going to have trouble giving away those H100s. I mean, H100 is great, don't get me wrong. And actually, H100 has better maturity with CUDA. Like, the big promise with CUDA is that CUDA is going to make your life really easy as you move from generation to generation. There have been some teething issues with Blackwell in that promise. There's some cracks showing in that promise. I mean, don't get me wrong, NVIDIA is moving mountains in a lot of different contexts, but for people that were really climbing the walls to move to Blackwell, there's a little bit of an early adopter tax there. And so they really are still selling a lot of H100s.
There are circumstances where Hopper is fine.
But if you're buying a platform for research or new stuff and you don't already have a bunch of existing stuff, get Blackwell or better or newer if you're watching this in the future. Now let's talk about AI as a workload for this. We at Level 1 have been quantizing DeepSeek models on the Intel platform because it has absurdly fast memory. This platform can support up to DDR5 8800 MRDIMMs. That is officially supported. You can spec that and buy systems with MR 8800. As configured, this system is with 6400. It supports 6400 out of the box. That is fantastically fast. And you may be thinking, wait, don't you normally use GPUs for AI? Well, certain kinds of workloads and certain types of research actually makes more sense to run on the CPU. And because you have 128 cores with a ridiculous amount of memory bandwidth, for a small pool of researchers, it may actually be much more cost effective to run this sort of thing on CPU. This machine, as configured, costs less than two RTX Pro 6000s. Well, that's street price, not necessarily MSRP, but it's the same ballpark. They're neighbors. They're in the same zip code, and that's kind of wild if you think about it. Now, the performance is completely different. That's not an apples to apples comparison, but that doesn't mean that CPU inferencing or CPU AI research is completely dead. It is absurdly useful, and that's what we're doing here. And partly because we don't have $250,000 to spend on a high-end AI system, but for doing quantization and for doing other types of research and just banging the tires for a small team of people, this works really well. As a storage platform with our Memblaze storage, I'm surprised at how well it works. You can have a lot of CPU overhead if you're running Ceph or ZFS or something like that. These 6980p CPUs with their absurd memory bandwidth make a great platform for a storage server that also does some type of processing. And ZFS has enough overhead that we can count ZFS as ZFS, like storage plus processing, because ZFS has kind of a lot of overhead. And so you add a couple of 200 or 400 gig NICs to this, and this becomes a really nice platform to be able to build with. If you're into hyperconvergence, or you're looking at replacing old enterprise gear in an existing deployment, a single socket solution is probably going to make more sense for you than a dual socket solution, if for no other reason other than power constraint. This system in a nominal configuration is going to be on the order of like 1,000 watts. And with 128 cores, if you're replacing or upgrading existing workloads, this is probably going to fit better within the existing power and thermal requirements that you may have in your data center. And 128 cores is still a hell of a blast radius for a single system. So if you have like a 5 or 8 server VMware cluster, for example, that you're looking at upgrading, you're looking at migrating, you're going to deploy something else, chances are 3 or 5 servers like this would completely replace, an 8 or more server cluster in an older configuration. And it's going to be probably slightly more, about the same, or maybe slightly more power and slightly more thermal load. But that is a much better configuration, is much better geometry than trying to replace a larger cluster with a very, very small number of machines from a maintenance, reliability, and failover standpoint. If you have a Ceph cluster or storage, or you're doing hyperconvergence, which means that you have storage for the VMs on the node, and you have the VMs on the node, and you have the stuff that does the failover and the monitoring and all of that, like the health check stuff, and it's all on the node. And then you have at least 3, 4 or 5 identical nodes. And then if one of them has a problem, you eject the node from the cluster. It makes a lot of sense to run with this kind of a configuration as opposed to a more dense configuration where you might have 256 cores or more. This platform also, I think, makes a lot of sense even if you're not going to run with a 128 core configuration. If you step down to some of the other processors in this family, but that are still 12 channels, a 6900 series Xeon, I think that makes a lot more sense for performance and longevity reasons than the 8-channel platform. The 8-channel platform can be compelling for certain workloads and certain use cases, but in terms of replacing legacy hardware, you can get a really good deal on this platform with 12 memory channels in the single socket configuration, and I think that works really well. Supermicro also has a 4-socket configuration, which is the best performance option, because each CPU has basically an insane power budget, because every socket has up to, its TDP value, and they'll run independently. And that's good for a density play, but that's also good for a memory capacity play. So if you need an absurd amount of memory, you can do that. 3 terabytes on this platform is within reach, even before you get into CXL modules. And don't forget that, in Xeon 6 has 128 to 136 PCIe Gen 5 lanes. So you have a lot of options here. Let's get to the benchmarks. You got to see the benchmarks. The benchmarks are really interesting. Now, for the benchmarks, I've gone to the trouble to do something interesting because there has been a lot of software updates from the Intel dev team. I mean, even though Intel has sunset clear Linux, it's clear that Intel has a lot of software developers, or had a lot of software developers, or continues to have software developers working on optimizations. And so even though the 6980p launched in the 2-processor configuration late last year, there are significant performance improvements for the 6980p, as I've shown in other configurations. Now, this configuration is a single socket configuration, so I've done other comparative single socket configurations. I've also included some data on the 8490H, but understand that the 8490H is a 2-processor configuration. So it's like, oh, can we consolidate 2 processor sockets down into one? Yeah, you totally can. There's, in the back of your mind, you have a little bit of a worry about memory bandwidth or something like that, but yeah, it's by and large, unless you really know your workload and you really know that that's not true, the generalization is that yes, you can absolutely consolidate 2 older sockets into one. And this also, you can get a feel for the 6980p is the best Xeon that Intel has done in 10 years, because that 8490H, not even 3 years old. So let's first look at the NAS parallel benchmarks, because I think these are really, really interesting. The comparison CPUs that we have here, the 9575F and the 9755. Now, the 9575F, that is a 64-core processor from AMD, but it's very special. Each chiplet has dual connections, so it's half as many cores, but each core has twice as much bandwidth to the I/O die in AMD's architecture. And that makes a dramatic performance difference for purely memory-bound workloads in AMD's configuration. The 9755 is the 128-core part. In a couple of these tests, I've done some different CPU configurations to try a few things. By and large, while Intel also supports sub-NUMA clustering and some knobs and tunables for the CPU, by and large, I don't really find it necessary to do that type of tuning on the Xeon platform. A lot of the time the software has been optimized for that. And you can see that in a lot of our NAS parallel benchmarks, the 6980p is pulling well ahead. The other processor that we have here is the 6781P, and again, that's a system from Supermicro that I reviewed separately. That's an 80-core configuration, but that is also 8 memory channels. All of our other systems here, except for the older 8490H, are 12 memory channels, and so this is as like for like as I can make it. And the 9755 is running at its CTDP of 500 watts. You got to do that on the Supermicro H14 motherboard, again, that I reviewed separately. So yeah, Intel is holding its own if you look at these benchmarks that are highly optimized for Intel's platform. If we look at the class IS.D NAS parallel benchmark, we can see the 6980p at 128 cores is holding its own with the AMD 128-core platform. The 64-core platform is pulling a little ahead of the 80-core platform from Intel, but this is probably because the 64-core AMD platform has 50% more memory bandwidth, theoretically. On the MG.C benchmark, even our old 8490H platform in the 2-processor configuration is keeping up here. It's curious, though, because I would expect that in the 8490H configuration, we're looking at something here that resembles memory bandwidth. Like in this particular NAS parallel benchmark, maybe it's going to be more memory bandwidth bound. That's what I would expect for the older CPU configuration. But our 9575F 64-core with the twice the memory bandwidth per core available, even though it's a 64-core part, is well behind where I would expect it to be. This may be a software optimization problem, and we'll see that a lot in the benchmarks. High performant conjugate gradient. I think there's something that is not quite right with this benchmark, because the 6781 and the 6980p are doing really well, but the 9575F, the 9755 doing approximately equal doesn't make a ton of sense here. Now, the 9575F can run this benchmark on all cores at 4.8 to 5 gigahertz, which is amazing at a 400 watt TDP. The 9755 is 500 watts, so it has a little bit more wattage that it can draw, and if you're in a lightly threaded or single thread, you'll see that in core boost. But high performance conjugate gradient here, it's more than twice as fast on the 6980p platform as the 9755. So this may just be down to software and math library optimization. And other benchmarks we'll see more cores is more better. The 6781p and the 6980p, less is more in our Pennant 1.01. The 64 core part here is doing the worst. Worst being a very relative and subjective term here, but very similar performance between the 6781 and the 128 core 9755, with the 6980p being significantly faster. Now this is the LeBlanc Big part of Pennant 1.01. If we pick a different Pennant 1.01, the Sedov Big model, then AMD is pulling well ahead here. The 128 core platform from AMD is doing significantly better. It just depends on the benchmark, and it depends on what you pick. As Compact 3D and Compact 3D testing from the Phoronix test suite, Intel's picking up some pretty significant wins here. This was also crashing for some reason on the 9575F. That was a slightly different software platform, and it's probably nothing. If you look at something like OpenFOAM, with a small mesh size, OpenFOAM is highly optimized. The math here, there's a lot of people spending a lot of time doing optimizations. It breaks down about how you expect. The 9755 and the 6980p perform really similarly. Interestingly, the 6781 also performs well, even though it's only 80 cores. However, for the execution time, it lines up. The 6980p pulls out a slight win here, but for practical purposes, the performance between the two competing platforms is really similar. If the mesh is a medium size, then the 6980p is able to handle that geometry just a little bit better. The Open Radius benchmarks is really interesting. This is one of the few places where the 8490H2 processor configuration pulls out a win. This is probably just down to cache or something magical that happens in a 2-processor configuration, which means that for your workload, you'd better it pays in some instances to really understand your workload. Blender 4.1, the BMW model, it's compute only, it's just math. The 9755 is pulling out a win here, but the 6980p is really not far behind. That's kind of the same story with Classroom and Fishy Cat and Barcelona. And the pattern kind of holds true for other pure rendering thing, LuxCore Renderer, OSP Ray. You can really tell that AMD sells a lot to Hollywood and rendering because those workloads have apparently been very optimized. Although OSP Ray 3.1, if we look at particle volume across a couple different configurations, the Intel 6980p is pulling a little ahead. If we're doing path tracing in 4K with OSP Ray Studio 1.0, again, the 6980p is holding its own. It's edged out a little bit by the 9755, but it's doing really well here. We want to do Intel Open Image Denoise. Intel's software performance improvements benefit AMD just as much as their platform. Both of these platforms have significant performance improvements for a lot of the Intel image manipulation stuff, and even Open VKL. So good job, Team Intel. And the performance, 128 cores to 128 cores, is really similar here. 7-zip and compression tests are a little bit of a win for AMD. If we look at Python benchmarking, we can see that Python benchmarking is also a bit of a wash between our 128 core parts. Our NumPy benchmark, though, is significantly faster for the 9755. Liquid DSP is an interesting one depending on which benchmark you pick and the geometry of what you're doing. The EPYC can be faster, or the 6980p can be faster. It just depends. Depends on what you're doing. Longer filter lets 6980p go faster. It's weird, though, because it's like, hey, okay, that's interesting. Let's give it a really absurdly long filter, because in a filter length of 32, AMD is on top with 128 cores, but 57, the 6980p is on top. But then if we pick a filter length of 512, AMD's pulling well ahead there. Now that's just single thread. What if we scale to 64 threads? AMD's pulling ahead there. But it is a filter length of 32, not 57. If we scale to 256 threads with that filter length of 57 and a buffer length of 256, yeah, this 9755 is scaling a little better. Now, TensorFlow and OpenVINO, when Zen 5 first launched, Zen 5 was faster with OpenVINO in pretty much any configuration you wanted to run. But for face detection FP16 Int 8 with the software updates from the Intel team, the 6980p is pulling well ahead. Intel has found some significant performance uplift that benefit even the older 8490H. I feel like AMD could probably go in and do some more optimizations and get their score up from 193, but right now the 6980p at 544.96, that has a significant lead. If we switch from face detection to vehicle detection, for some reason, AMD has a little bit more optimization here, and the 9755 will pull a little ahead of the 6980p. And it's able to do it in fewer milliseconds. This suggests that maybe the cache hierarchy or the cache geometry on AMD's processor benefits a little bit more specifically for vehicle detection in this one benchmark. But that also suggests that the difference between face recognition and vehicle recognition could be optimized out of the platform. In other words, you could get similar performance from both platforms with the right software optimizations. If we want to do person, bike, and vehicle detection, we can get better overall performance out of the 6980p, but interestingly, the latency on the AMD platform is less. For machine translation, we have better overall performance and latency on the 6980p platform, although the 6781 80-core platform with its 8 memory channels is the lowest overall latency here, which is maybe an interesting result. SpeedDB, I think that's how you say it. And SpeedB, it's a drop-in compatible replacement for RocksDB. It's a really interesting project. They're doing a lot of really interesting things. So what's interesting is, with SpeedDB being a drop-in for RocksDB, okay, let's get a random read RocksDB baseline. It's pretty similar performance between our 128 core parts. AMD's a little ahead here. If we look at SpeedDB for random read, we can see that it's much the same story. Proportionally, things are about the same, and SpeedDB is also just a little bit faster. So drop-in replacement for ROCks, but very similar performance if we look at both of those as a baseline. However, let's look at reading while writing. The 6980p juggling a mixed workload, where it is read while write, is pulling significantly ahead of the EPYC 9755, 128 core for 128 core, remember. I thought this was really interesting because there were a lot of workloads where if you were doing something more heterogeneous in the workload, or the workload could be described as more heterogeneous, the 6980p would have, some type of an edge in that benchmark. Whereas just in terms of like sheer unadulterated compute, the 9755 is holding its own. So this is why I think it's important for you to understand your workload and understand what it's doing under the hood in order that you can, make the appropriate system selection. For algebraic multigrid and some of the encryption stuff we'll take a look at in a second, the 6980p is pulling out a little ahead, whereas, with WRF, the AMD platform is pulling a little ahead, and the 64 core with its high single core clock speed is definitely out in front here for this particular benchmark. Lulish is pulling out an impressive win here for the 6980p. Mini Butte is an impressive win for the 9755. If you're running LAMP's molecular dynamics simulator, the rhodopsin protein, it's going to be just a little bit faster on that 6980p. Similarly, simulating 20,000 atoms just a little bit faster on that 6980p. NAMD is another really super optimized platform, and the performance between our 128 core parts is really, really similar. The slight edge going to the 9755. And the 9575F with its slightly higher single core clock speed is the fastest overall. It's a bit of a wash with Gromax, 128 cores, core for core, like for like. Similar performance, at least on the GMX50 Bear water model. I love looking at the cryptography tests. So OpenSSL 3.3, AMD and Intel are both killing it here. The AMD platform is pulling a little ahead for RSA 4096 and SHA 256 operations. SHA 512, AES 128, however, is a very similar performance parity for both platforms. Notice that OpenSSL 3.3 is significantly faster than OpenSSL. OpenSSL 3.3 has a lot of optimizations in it for AMD's processors. And so if you were just to run the older OpenSSL benchmark, it's like, oh, Intel's way ahead here, the 6980p. It's like, not so fast. OpenSSL 3.3, you get very similar performance. And this is, a lot of this is because the, AVX improvements on the AMD platform, but has OpenSSL been updated to use AMX? This is historically what Intel developers would be in there doing. It's like, okay, we're going to update this for our AMX platforms. We're going to be able to handle an absurd number of crypto transactions. And there are some math benchmarks and there are some things in the suite here that have been updated for AMX. And for the things that have been updated for AMX, the 6980p is going to pull well ahead because it's got more capabilities in that regard for those types of operations. It's really interesting to look at. For AI type workloads using the ONNX runtime, things are a little bit more rosy for Intel than they are for AMD. I mean, our 9755 is 11.97 inferences per second and 83.57 for the inference time cost. And you can see here that our 6980p is doing a fair bit better than that in this configuration, 128 cores for 128 cores. Even our 80 core part is doing pretty well on its own. It's a little faster because it's not super heavily threaded. You'd have to thread this down to a whole bunch of things, but YOLO V4 running on CPU, pretty good here. So overall, bottom line, the 6980p is still the best Xeon that Intel has done in 10 years. But you can see how much of an improvement AMD has had from Zen 4 to Zen 5. And so depending on what your workload is, you can have certain things that are faster on the competing platform and certain things that are faster on the 6980p platform. But the 6980p is a viable processor in 2025, which is amazing. The thing that Intel has to do now is focus on execution. And this is also showing that, you know, single socket versus dual socket, like a single 6980p system can handily replace many systems of prior generations. I mean, the 8490H was, you know, at the top in a less than 3-year-old processor from Intel, and it is entirely supplanted and replaced in 99 out of 100 scenarios with that 6980p. That tells you how far Intel has come in just a few years. And so if Intel is able to consistently execute on this cadence and deliver systems like this, there's a lot to be excited about. Now, in addition to the compute benchmarks, like I say, my Memblaze Gen 5 U.2, these are coming. This is really nice. Memblaze, this is you know, Chinese Asian storage, and they've been around for more than 5 years, and they're making a name for themselves. And I put a lot of mileage on the 7A40s that I have. I've been very impressed with the performance in like a Ceph type workload, virtualization, and hyperconvergence. You know, if you're in the Pacific Rim or you're in that area and these are available to you, it's been really interesting taking a look at that. But that's going to be in another video, not just with this chassis, but also the 6781 chassis, which is the 8 memory channel single socket configuration. And so like moving between those and trying some different RAID options. We got some really interesting stuff coming with that. So this has been a quick look at our SuperServer 212HA-TN. It's Hatton. It's HA-TN. Thank you very much. Well, let's just get on down. I'm super serial.